Welcome. In this lesson, we're going to take a look at a new concept called a polymorphic reference. Let's get started. We've got two learning goals for today. The first is that you can explain and create polymorphic references, and the second is that you can describe situations where polymorphic references are actually very useful for solving problems. If you've been watching the lessons up to this point, you've seen this slide already, but just as a quick review, recall that this is all dealing with inheritance, which is a relationship where a subclass inherits the variables and methods of a superclass. For this lesson, we're going to use the example that we've been using for a while, which is the person superclass and the student subclass. Notice that a student has a GPA and a schedule, but they also inherit the name and birthday from the person superclass. The line of code that you're seeing right now creates a person object. Remember, that's the superclass. And remember that when we make an object, we're actually making two things. We're making the object itself, but also a reference to that object. Here's the memory diagram kind of explaining what I mean. When we have the code person P, that's actually creating a reference. Remember that objects are stored in the memory as references. And then when we say new person, that's actually creating the object. Now, if you feel like you don't remember too much about references, you can find information about that both in Unit 2 and in Unit 5. There are lessons covering those concepts that may be helpful to you to take a look at. Again, looking at this line of code that creates a person object, what you can see is that the reference on the left and the object on the right both have their own type. Usually these types are the same, right? We say person P equals new person. It's person on both sides. The reference is a person and the object is a person. And up until now, that's kind of how we've always made our objects, right? We might say rectangle R equals new rectangle, or circle C equals new circle, and so on. So usually the reference type and the object type are the same, but not always. Here we create an object where the reference type and the object type are different. In this case, we say person P equals new student. Now, we've never seen or done anything like this before, but Java does allow it as long as the object type inherits from the reference type. In other words, the object type student inherits from person. Person is the superclass, student is the subclass, and this is known as a polymorphic reference. Another way to think about this is using the terminology that we talked about in earlier lessons with the idea of an is-a relationship. And an is-a relationship was a way of describing inheritance, where basically the subclass is a more specific version of the superclass. So a student is a person, or you could say an apple is a fruit. And so by that reasoning, when we say person P equals, what we're allowed to do is put anything over here that would be a more specific example of a person. Let's pause kind of here at the halfway point and do a quick understanding check to make sure we're on the same page about what is and is not a valid polymorphic reference. I've gone ahead and put the class hierarchy on the right for your reference, and then on the left, I've got 6 attempts at creating a polymorphic reference. Some of them are valid, some of them are not valid, and I want you to identify which ones are valid and which ones are not valid. Keep in mind that to be a valid polymorphic reference, the object must be a more specific version of the reference. That is our relationship. So pause the video, and when you're ready, we'll take a look at the answers on the next slide. To be a valid polymorphic reference, the object on the right must inherit from the reference on the left. So for number 1, person P equals new high school student. The object is high school student, and it does inherit from person, so it's valid. Number 2, student S equals new high school student. High school student is the object, and it does inherit from student, so it is valid. Number 3, student S equals new worker. Worker is the object, but it does not inherit inherit from student, so it is invalid. Number 4, high school student H equals new student. So student is the object. It does not inherit from high school student, so it is not valid. However, number 5, person P equals new worker. Worker does inherit from person, so it is valid. But number 6, the opposite is not true. A person does not inherit from worker. Now that we have a sense of what we're allowed to do with polymorphic references, I think the big question is why. And so there's 2 typical use cases for polymorphic references. One of them is generalizing method parameters, and the other is creating and processing arrays and lists with multiple data types. And we'll take a look at an example of each of those in the next slides. Let's consider a method called printName, whose job it is to print the name of a person object. Okay, pretty simple method. Notice that the method takes one person as a parameter. So in other words, we're going to send a person object to the method, and the method is going to print that person's name. Typically, when I want to call a method, I have to match the parameters it's asking for. For example, if the method requires an int parameter, I have to send an int. If the method requires a string parameter, I have to send a string. And this method, printName, requires a person. So the first time I call printName, everything makes sense, right? I say printName of P, and if we look, P is indeed a person object, and everything works. But then I call printName again, and I send it S, and S isn't a person, not exactly. S is a student, yet it still works. And the reason it works is because of polymorphic references. Remember that person P can point to a person, but it can also point to any object that inherits from the person class. So now this printName method will actually work with not just a person object, but a student object, or a high school student object, or a worker object, or whatever. And what's awesome about polymorphism is I can actually write the method once, but I could use it for a lot of different types of objects. And so that's one use case for polymorphic references. The second use case for polymorphic references has to do with arrays and array lists. So in this example, I've created an array list, and notice that it is an array list of person objects. But because polymorphic references are a thing, I can add anything to the array list that inherits from person. So I can say add new person, add new student, add new student, add new person. I could keep going, right? I could add new high school students, I could add new workers, and polymorphism allows the array list to hold all objects that inherit from the person class. Now that I've created my array list, let's suppose I want to print all the objects in the list. And for that, I have just a simple for each loop. I say for person P, remember the array list was declared as type person. For each person P in the list, system.out.println it. Now, how can this work? How can we printline when some of the things are persons and some of the things are students? And not only are the types in the array list different, but they have their own unique toString method. And remember, when we printline an object, it calls the toString. So for person objects, we have one toString. And for student objects, we have a different toString because we want different things to be displayed. So how does all that work? So when we go to print this array list, we've got 2 different types of objects, and each of those objects has its own toString method. How can this code handle kind of both of those at once? And the answer is that Java, what it will do when we're going through each person P in the list, it's going to take a look on the fly at what type of object we're printing. And if it happens to be a person object, it will automatically know to call the person toString method. And if it identifies it as a student object, it will automatically call the student toString method. And this is a process called dynamic binding. And really that just means that on the fly, when the program is running, that Java will bind the method call to the correct method based on the object type. In other words, it just figures it out as it goes. On the right, we have the output of print lining all the elements in the array list. And what you can see is that because the first object and last object were persons, we get one toString, and the middle two objects were students, and so Java automatically called their toString. And so it's really cool that Java can figure that out on the fly using that dynamic binding. So let's conclude with a final understanding check. And I specifically want to talk about this last example where we had an array list of person objects, but the array list actually stored both person and students. The question is, what's exactly the advantage of being able to do this? Why would I want to be able to put multiple types in the array list, and how could this save us some effort? So I want you to take a minute to think about that, and then we'll talk about the answer. So pause the video and restart when you're ready. Having an array list full of polymorphic references is a pretty typical use case, right? The array list is declared of the superclass type, and then we fill the array list with objects of the subclass types. This can really help a lot, and if we couldn't do it, we would probably have to make multiple array lists. So in this case, I would need an array list of student objects and then an array list of person objects. And perhaps it wouldn't stop there. Maybe I would need another array list of high school student objects and worker objects and so on and so forth. It could be a lot of array lists if the system is large. And not only would I need multiple array lists, but I would also need separate loops to process each array list because they're probably not the same size and they have their own methods to call and so on and so forth. But with inheritance and polymorphism, I can actually put all of the objects in one array list and I can process them with one loop, and when I call a method, it will automatically call the correct method, as we saw it called the correct toString method, even though there were two different object types. And so in a large system, this can save an insane amount of code. Now that you've seen this lesson, you should be able to explain and create polymorphic references and also describe situations where polymorphic references are useful for solving problems.